Here I am again, this is Mark, Evo Ballistics, and in this short video I'll show you the dispersion radius module for the EB Mark I and how to make use of it. As usual with the analytics modules, we start off on the screen and then go to our dispersion radius tile down here. What you see here is a graphical representation of where your shots would land in relation to each other compared to the center of the target. What we see here right now is we have a series of, in this case, 29 shots and a distance of 600 meters. When pressing the shot select, we can also see that in this case it was a SIG 516 patrol version with the S&B 223 Remington ammunition, and I can select and deselect any shots that I like here. We can of course change our series, but in this case we'll stay with the series because it's a good example here. Now, we can select here in our target configuration how large we want our different diameters for the rings to be. We have 3 different rings and a percentage dispersion that we can accept here. What we see here right now is that in the central ring of the 29 shots, 14, so 48.28%, would land within the central ring with a diameter of 10 centimeters. Another 12 shots would be within the 30 centimeter ring, and the last 3 shots would be within the 50 centimeter ring. There is no shot that would be outside of the target. Below the target, you then see the different group sizes for the maximum dispersion. So all shots are within 36.2 centimeters here, and 90% of the shots would be within 25 centimeters, 50% would be within 10 centimeters, and the 33%, this is what I can input here. So a third of the shots would be within less than 9 centimeters in this case. This is a significant improvement over a lot of other systems because this allows you to understand how your ammunition performs at different ranges. So in this case we have right now 600 meters selected. If we were to drop this distance or increase it to, let's say, 800 meters, after a couple of seconds of recalculation for every single shot, we then see that only about a third of the shots is still in the center of the target, and a third shot is actually outside of the target area. And that is just by increasing the range by another 200 meters. But however, everyone knows that 800 meters is really pushing it for the 223 caliber. But this is just as an interesting example of how the accuracy actually significantly drops at longer distances. One of the most interesting features here that I think are useful is the effective range calculation. This allows you to enter a maximum group size that you would like to see, and it will calculate for you the range at which this group size is achieved. So in this case, for the 30 centimeter group size, is achieved at 577 meters. Now, it would be interesting to see what happens if we reduce the number of shots by dropping away the most extreme outliers. So let's get rid of the 926 meters, 925 meters per second. Let's see if we have another one. Yeah, 926 here. And we see all the other ones are very close to 900 or 910. We've got 123 here. And we'll just get rid of these couple of shots. So that was just 4 shots that we have removed now. And now it's recalculating our effective range. And we see that it has now increased from 577 to over 626 meters. And that was just by removing the couple of shots. And we see that we are now displaying 25 of 29 shots in this series here. And we can of course also change the maximum group size. So let's say we want to have a maximum group size of 20 centimeters. We will now recalculate and we get a result of 554 meters. So almost the same as before, but just having removed the 4 shots here. And this is how you can really quantify the quality of your ammunition at different ranges without actually shooting at those ranges. And I hope this was very useful for you, because I believe this is one of the most interesting modules that you can use for quality ammunition to understand what your rifle can do with that ammunition.